Aquaba to the math classroom. In our lesson today, we are still discussing the general solution of a differential equation. If you've not watched my video yet on the solution of a differential equation, kindly I urge you to do so. Find the link in this video. So we want to determine whether the function phi of this is actually a solution of this differential equation. So we know what phi is, and this is the differential equation. To check whether it's a solution, one way you can look at it is finding the derivative of this function plus the function, and if it's equal to 0, then we can say this function is a solution towards this differential equation. So this is what the second derivative. So we first have to find the phi. So the phi over the x. What is the phi dx? So this is what our function. So we do differentiate with respect to what x. So if I differentiate this side, a is a constant. If I differentiate cos x, what do I have? I have minus what sine. Don't forget your a, our constant is a constant. So I have a sine what? X. If I differentiate sine, what do I have? Cos. So I have plus b cos what? X. So this is for the first derivative. Now let's look at the second derivative. Phi over the what? X squared. So we differentiate the first derivative again. So if I differentiate sine here, I have what's called. So I have minus a cos x. Then if I differentiate cos, I have what? Minus sine. So I have minus b sine what? X. So this is what the second derivative. It says this plus the function is equal to 0. So let's check if we are getting 0. So you realize that from here, what do I have? I have, so this implies that I have what? Minus a cos x minus b sine what? X plus the function. The function is what? This a. So plus a cos x plus what? B sine what? X. So what do you see? You have a cos x, a cos x. So because this is negative and positive, so this cancels out and this also cancels out as well. So this thing is what's equal to what? 0. So with this, we have been able to show that yes, indeed, the function is a solution to the differential equation. So it becomes what? The general solution. Let's take another example. Let's say I give you the differential equation. So let's say I have the differential equation y prime prime minus y to be equal to what? 0. And I give you the function y e exponent what? X, the constant c e exponent x. Then let's also give you the function y to be equal to e, the constant. So I have a constant c e exponent what? Minus x. Let's check whether these two functions are a solution to what? The differential equation. So how can we go about it? So let me pick the first one. We have y to be equal to c e exponent what? X. Let me find the first derivative, that is differentiating with respect to x. So I differentiate the power exponential function, you differentiate the function at the exponent. So if I differentiate this, what do I have? I get 1, you multiply by the whole thing, you still have c e raised to the power what? X. If I find the second derivative, y prime prime, for this, what do I have? I still have my constants. If you differentiate this, you still have e to the power what? X. So let's check. So I have from here, if you substitute, what do you see? You realize that I have this y prime prime is c e raised to the power x minus y was what? C e raised to the power x, which is equal to what? 0. So you realize that y to be equal to c e raised to the power x is what? A solution. If I take the second part where I have y to be equal to c e raised to the power what? Minus what? X. Let's find the first derivative. What do I have? If you differentiate negative x here, you realize that you have minus 1, so I have minus c e raised to the power what? Minus what? X. Let's do it for the second time, prime prime. If I do it for the second time, prime prime, what do I have? You realize that I have, because this is negative, I multiply to get a positive, so I have c e raised to the power minus what? X. So let's do the substitution in c. So what do I have? I have c e raised to the power minus x minus y. Y was what? C e raised to the power what? Minus x, which is equal to what? 0. So this implies that c e raised to the power minus x is what? A solution. So that's how to check whether a function is a solution to the differential equation when it is what? Satisfied, when y and its derivatives are replaced by the function we are looking at. Thank you.